Hello, and in this video we will be looking at how to determine whether functions are even or odd based upon the graphs themselves and based upon looking at an algebraic method to check. This is a worksheet that you can find in your document folder, so if you want to pause this and try out the document, work on the problems first, and then come back to this to check your work. You might want to do that first. So this is going over another value in your document folder in section 2.3. So we're going to start off with testing this by looking at the symmetry. Okay, so what we're looking at here is even. Even has symmetry with respect to the y-axis. So what we're going to be doing is we're going to be looking down this line and seeing if we can fold and have matching values on either side. So if we look on this side of the graph and we see something over here, we should also see the same thing on the other side at the same place. If we look at this one's not even, so it's not even because it doesn't have symmetry on the y-axis. You're not able to fold along the y-axis. This value over here is not matched up with the value over on this side. This one right here, if you look at it here, you can see that there's a value on this side of the y-axis. It's the same height over here. And it follows throughout that they have similar values on either side of the y-axis. So we're going to say this one is even. All right, so that one's done. We figured out it was even. We don't have to check it for anything else. It can be even or odd or neither. So what we're going to be looking here, let's check this one out. So if we check on this one, we go to the right here of the y-axis, and then we go to the left. We do not see something over here graphed over there. So this one is not even also. This one's not even. So now we're going to check for odd. We need to check the non-even ones for being odd. So now in the odd functions, odd, it has symmetry with respect to the origin. So origin and odd, meaning that this is a rotation. This one, origin rotation, is a rotation of 180 degrees about the value 0, 0. Rotation about 0, 0. So that's what we're looking for, is a rotation about 0, 0. So we're going to see if we take this point and we rotate it 180 degrees, does it match up over here? So this one seems to match up right there. We rotate this 180 degrees, we get over here, that's good. So this one's going to be odd. There is a rotation here. Another way to check this is to put your paper down right here, put your pencil right on that paper, and then turn your paper upside down. And if you see the same graph upside down as you see right side up, then it's going to be odd. So we've checked this one, it's odd. We already know this one's even, so we don't have to check it again. It's even, odd, or neither. So let's check this one over here. So if we take this point and we rotate it around 180 degrees, we should get something over here, and we don't have something over there. So this one's not odd either. So this one is going to be neither. So we would say neither on this one. So you're going to have three choices for this type. You're going to have odd, even, or neither. Now let's take a look at these with respect to the equations themselves and test them out using the equations. So if we're going to use the equations, then we're going to be looking for whether the value of f of negative x, that means the opposite value of x, is it going to be the same as the value, or is it going to be the opposite of the value? So the opposite value goes in, and we see if we get the same function or the opposite function. Not the opposite value. The opposite value gives you the opposite function, then it's odd. If it gives you the same, then it's even. All right, so we had the same graphs up above, but we're testing these. So let's take a look at, so in each one of these we're going to evaluate f of negative x. So everything we do, we're going to take the opposite value here in each one of these. And we're going to look at each one as if it was an f of negative x. And then we're going to take a look at that to see whether or not we get exactly the same, right up here, exactly the same, or do we get the opposite of it, which is this value right here, the opposite of it. If we don't get either one of these, the opposite or the exactly the same, then we're going to write neither. So each one of these is going to be plugging in a negative x. Now I'm going to use parentheses around those values, and so I can plug in the negative x here. So this one's going to be negative x cubed minus 2 times negative x. Okay, so when I'm working this one out, we're going to say f of negative x is going to equal, well, that's going to be negative x times negative x times negative x, which is going to be negative x cubed, because it's negative times negative times negative. And then this one is a negative 2 times a negative x, so we're going to get positive 2x. So we're going to look at this graph and see if that's the same as, and in this case it's not the exact same, so we would want to look at how it compares to this function right here. Is it the same as that function? It's not even. Because it's not the same. All right, now we're going to check for odd. To be odd, it has to be the opposite. So we're going to look at negative f of x, which is basically negative 1 times the function. So if we take the function and we multiply it by negative 1 times x cubed minus 2x. The question is, when we do that, we're going to get negative x cubed plus 2x. And that function is the same as the one we got for negative f of x. That's the same. So those are the same. Therefore, this is odd. So if we get a function that's exactly the same as the function, it's even, so it's not even, but if we get the same as negative 1 times the function, which would what we did, then it's going to be odd. If these two don't come out to be the same as the one with the negative x, then it's going to be neither. So let's check the second one here. So if we plug in the negative x here, we're going to get negative x parentheses squared minus 4. Now if we square a negative x, that's going to be positive. Negative times negative is positive, so we get x squared minus 4 again. And since these are the same, then it's even. So this one's even, so it checks with the graph up above. So far we've got the same as the graph. The first one was odd, second one's even, the third one's neither. So let's check the third one. I'm going to draw a dotted line down here so you can see that where my work is going to be different. So on this one we're going to put in a negative x, so we're going to get 3 times negative x minus a negative x squared. Ran out of room a little bit here. So that function is going to be negative 3x. Now when I square this negative x here, when I square that negative x, it's going to be positive, but then I have this negative here, so it's going to stay negative x squared. So we look at this function and we compare it to the original. It's not the same, so it's not even. And then we want to compare it to negative f of x, which is the negative 1 times f of x. So if we do that, that's just going to change the signs and give us 3x, negative 3x, plus x squared. And those are not the same either. These are not the same. So it's not odd. So that means it's going to be neither on this one. Now, you have to check to see if it's the same. If it's the same as the negative 1 times it, then it's odd. Or if it's neither one of those, it would be neither. So if you have any questions, you can send me an email about even and odd functions.